Welcome to my third video of becoming crypto literate. So today we'll talk about finality of transactions, especially on the Extrapolator, but also applied to generally all the blockchains. Alright, so let's start with, we've got the Extrapolator or any other blockchain technology, and on the Extrapolator there are the account balances. For example, I've got my account, an xrpdev account, for example, has an XRP balance of 1000 XRP. Alright, so let's add another account there, and we've got the second account, whatever. Let's just call this account Alice here, and the account Alice has a balance of 300 XRP or 200 XRP. Alright, and in order to interact with the blockchain, we need wallets. So I've got, for example, in my case, I'm going to say I have some wallet here, with which I manage my the xrpdev account, and I want to do a transaction now. For example, if I want to do a transaction, I'm telling the Extrapolator, so this thing here, this yellow thing here, that entire thing is the Extrapolator, okay? So I'm going to also write it down somewhere else. So let's just use a text here. Maybe I can use a text or something like that. Down, where's the plus? Text, there it is. Okay, great. And I'm just going to add a text here. So that thing here, this entire thing, that's the Extrapolator. And the Extrapolator knows the balances of all the accounts and not your wallet. And using the some wallet or any other wallet, I can interact with the Extrapolator. And in my case, I'm telling the Extrapolator signed request. So I'm telling the Extrapolator, please send 200 XRP to Alice. Okay, so it obviously looks a little bit differently there, but I am with the some wallet, I'm signing a transaction, telling the Extrapolator, yep, please send 200 XRP from my account to Alice's account. So the Extrapolator updates the state. So now my account has a balance of 800 and the account of Alice has a balance of 400. And also it writes down the transaction that happened. So there's a payment transaction happening. It's a payment from to an amount from, I'm also going to quickly show you. Finality.xrpdev.org. I'm going to quickly show you what the payment looks like. So right now it's just an explorer here, and if you look at the green one here, that's what the payment looks like. So it's a transaction from one account to another one. So in this case, it's sending a token. I'm just going to look for one using xrpdev. So let's try a few. Maybe we'll find one. Whether it's actually, the one before, that one here. Yeah, so we can see here that this, okay, it's an offer crate, my bad again. Alright, yeah, here we can see that in this case that this is a so-called payment, so we can look at the raw JSON here, and that's what, so that's already the change though, the change here. Yeah, that's the, it's the raw transaction. So this is what the transaction looks like. So you can see from whom is it being sent to, how much is being sent. So in this case, this is a drop, so not the whole XRP. So we have to go to use 6 of these numbers, because 1 million drops is 1 XRP, and you can see that this person is saying 930 XRP to this account here. And I remember that this is probably the account of Binance. But it's not that important, so that's where it's being sent to, and that's what the transaction looks like. And then the Extrapolator, if the transaction is being signed properly, then the transaction goes through, and the change is being applied to the blockchain. As soon as the change is being applied, then there's no possibility of reverting that. So the Extrapolator, as soon as the ledger closes, the change is immutable, so it's unchangeable and irrevertible. So each ledger, as soon as ledger is being closed, then it's not changeable anymore. There's no yes, revert or undo or something like that. Okay, that's why it's very important to also verify where you're sending to, because if you're sending it to another valid XRP address, then you can't retrieve that anymore. As you know, I can generate as many XRP addresses as I want to. There are millions and trillions and so on, so it's a huge number. So whenever I change stuff, that's a valid XRP address. If you send XRP to this address, you won't be able to access it unless I'm storing this one. There are endless amounts of valid XRP addresses. So you see that all of these are valid XRP addresses nobody has used before. So also maybe somebody owns that, but the chances that I randomly hit somebody else's is very low. So if I just change the pattern again, it's a very long string here and case sensitive, And all of these are valid XRP addresses. If you send XRP to this address, for example, then I'm not able to retrieve it unless I know the family seed, so the private key to the account. And that's also the important part about these giveaway scams. As soon as you send your XRP to another address, you're not able to undo that. It's final and immutable. You cannot change it anymore. That's very important to understand. And this is also the same case scenario for other blockchains. For example, let's use Bitcoin. On the Bitcoin network, a transaction can be considered final after a certain amount of transactions. So on the Extrapolator, it's final after 3.8 seconds. On Bitcoin or on Ethereum or on any other proof of work blockchains, it takes some time because it's not being processed altogether. No, for example, a Bitcoin blockchain, each block which is added, so as soon as a block is mined, including all the transactions, it's being propagated to all the other nodes, and it takes some time until all the other nodes have also accepted the change and written it down. And so that's why, for example, that certain exchanges, if I just enter Coinbase Bitcoin deposit, well, they are telling you how many confirmation it needs until it's being added to your balance. So, for example, on Coinbase, a Bitcoin transaction is considered unconfirmed until it has included blah, 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 at which point it has one confirmation. Each additional block is another confirmation. Coinbase requires 3 confirmations. So in Coinbase, it requires 3 nodes at least to have also added, it and confirmed it until it's considered final. So that's why it takes a little bit longer. For example, if you try to deposit any proof of work blockchain technologies to your account. Yeah, as soon as the transaction is considered final, it's irreversible. So yeah, so in this case, like I said, it could be also the case that one node is misbehaving. So on Bitcoin, on the Bitcoin network, and that's why they're saying, well, 3 nodes can't be wrong there, so at least 3 nodes. And yeah, on the Extrapolator, like I said, after the ledger closes, the transaction is final, and there's nothing you can do about it. So always make sure that you know where you're sending it to. Also, there's another lie or misconception out there that any address is valid. That's not true. So, for example, if I have this address here, and there's this common misconception, yeah, but what if you have the last letter wrong? What is the lowercase v? Then it wouldn't work. There's a so-called checksum at the end. So if I would, for example, take this address, so this one is a valid address, okay? If we try to send XRP to a valid address, so I've got, right now I'm going to test it here, and if I would try to send XRP, let's say send to this address here, that's a valid address, and it's also telling me it's not activated. But if I would change it to lowercase v, invalid address format. There's a so-called checksum in there. It's checking, so there's this common, this common misconception, yeah, but what if you write one letter wrong, uppercase or lowercase, and then suddenly it's gone? That's not true. The chances of you luckily entering it correctly is the chances 1 to, so the chances, sorry, I'm just going to calculate it, 1 out of 2 to the power of 32 minus 1. So it's ridiculously low, okay? So the point being that the chances of you luckily entering correctly and that it's still a valid address is very low, okay? So like I said, there's a so-called checksum in there, and that's why it will always detect. So this one is a valid one. If you change anything in there, it doesn't work again, okay? All right, anything else to mention here? Right, so we can also do that now. I'm gonna send from this account here, some XRP to the other account. That's not activated yet. Oh, it's activated. I'm going to send 20 XRP from this account to the other one. It's confirmed. Right now on the testnet, so that's not. So the testnet is maintained by Ripple themselves. So this one is, like I said, quote unquote centralized. So it is because it's a testnet. It's fine. But the actual Extrapolator is not centralized. It's decentralized and permissionless. So that's also why, if you, for example, like I said, right now I send 20 XRP from this account to the other one, and I cannot reverse it from here. The only thing how it works that I would get the 20 back is if this account says, well, if the account owner of this account says, well, I'm going to send it back to you because there must have been an accident. So it must have been an accident that you've sent it to me. Then I can also say, well, there you go. I'm going to send 20 back to you. Then it's also coming back to this account here. Right, and after it's final, then yeah, nothing can be done about it. Also, one last thing, so if you're scammed out of your XRP, then you can contact Ripple and tell them, yes, Ripple, please undo that. It's not possible. It doesn't work. Like I said, the Extrapolator is permissionless and decentralized. Ripple cannot undo a single transaction. Ripple cannot undo any transaction. They have no special permissions or powers. Alright, so that's it for this video. I hope it was helpful in becoming more crypto literate. Thanks for watching and see you in the next video.